So thanks everyone for being here. It's an honor to be here with you and to talk about climate change and hopefully bring the world a step closer to a solution. Today, starting us off, we're going to have Professor Thomas Stocker from the University of Berne, who is a professor in climate change physics. From 2008 to 2015, he was co-chair of the International Panel on Climate Change, the IPCC from the United Nations. And we're excited to hear what he has to tell us.
So welcome everybody. This is a cozy little meeting, but nevertheless I hope we can make it interactive. So I would just offer to you to interrupt me whenever you see something unclear and would like to have an explanation. But I can also say after 30 minutes or so there will be enough time for questions and answers after Ruben's intervention. So what I want to tell you today is really the key message that if you look at climate change and the climate crisis, there will be all these messages about crisis, and I will show you a few. I won't spare you of that. But at the same time, doing climate protection and realizing that we have to do something in order to avoid damages and all the effects that a crisis entails, it's also an opportunity. And I think that's the message I want you to go home with, that this is an incredible economic opportunity. So let's go to the facts. So you see here a graph of the global mean temperature change. This is something abstract to all of us. It's based on millions of temperature data measured at the surface of the planet since 1880, homogenized by several different independent and competing institutes. And the data that you see before you clearly shows that something is happening to the global mean temperature of our planet at the surface. After several decades in the 20th century of natural climate variability, that is the up and down that you see on these individual dots of this red curve, since 1970 around, we have a continuous increase of the temperature with a trend that cannot be ignored. There are a few years, around 1998 to about 2012, that some people 10 years ago have called the warming pause. I even got some questions by journalists. When do you, Professor Stocker, admit that there is no global warming, based on the fact that in the last 7 to 8 years we haven't seen a temperature increase? Well, now after 10 more years of temperature measurements, you can hardly recognize this warming pause, which isn't really a warming pause. It was just an expression of natural climate variability in the system of the atmosphere, the ocean, the sea ice, the land surface, etc. It's a highly nonlinear system, and as you can see, there is natural climate variability as we know it. One prominent example is El Niño Southern Oscillation or volcanic eruptions that can also interfere with the global mean temperature. 2021 was amongst the hottest years on this record, and you also see, if you take a decadal view on this, many of the years past, in fact 18 of the past 20 years are among the warmest years since 1880. Now, overall, we can say that the climate system has warmed about 1.1 degrees Celsius in the global mean over the 20th and the beginning of the 21st century. With the temperature, also other variables in the climate systems change. One of the prominent variable that you can appreciate is important to humans and ecosystems is precipitation. And you can see here the percentage change in, the millimeter per day per decade change, again based on measurements since 1984. There are clearly significant trends here that we can tease out of the data. Where you see brown areas, you have a drying. Where you see blue areas, you have an increase in precipitation. So with temperature, also the water cycle has changed. Now, if it's getting warmer, then we expect further consequences in the climate system. For example, we would expect a melting of the ice bodies on the planet, and that is in fact what we measure. Thanks to satellite missions that have been operative since the beginning of the 21st century, we can even measure the weight of Greenland and of Antarctica. Measuring the weight, that is something that is hard to imagine, but with highly precise gravimetric measurements of 2 trailing satellites, we can essentially measure the weight of Greenland on a monthly basis. You see here the seasonal variations of the weight. In winter, Greenland is gaining mass. In summer, it's losing mass, but overall, the mass balance is negative. So every year, Greenland is losing about 400 billion tons of ice. It's losing it to the ocean, where it melts and contributes to the rise of sea level. The same we observe in Antarctica, a significantly colder place. And so it is surprising that also there we find a shrinking of the mass, as you can see here in the right graph. While on the surface, the mass balance is still more or less constant with a small trend in the last decade or so, that's the blue curve. The purple curve is the overall mass balance, which comprises also the periphery, that is the region where the Antarctic ice body meets the ocean that already transports warm water towards Antarctica. Both curves of these massive ice masses show a loss, but what is more alarming, they show an accelerating loss. You see the curvature of these 2 curves points down. The loss per year actually increases with every year. Just for you to get a take-home number, this is incidentally a picture that I shot out of a rapidly moving ice stream from Greenland. This is Jakobshavn, Isbry. You see here the terminus of the ice stream in front, where it's the regular surface. That's already ice floating on the fjord, ocean water, and a huge iceberg here has been released from this ice stream. Just to give you the dimensions, the front edge here is 30 meters in height. So easy number to remember is that Greenland, at the net balance, loses about 1 cubic kilometer of ice every day. Antarctica, about a third of it, 0.3 cubic kilometer per day. And it's an easy back-of-the-envelope calculation to find out how much that contributes to the annual increase of sea level. It's about a third of the global sea level rise. Now, the origin of these changes, the increase in temperature, the change in precipitation, the melting of the polar ice sheets, that is all due to one ingredient, and that is the greenhouse gases in the atmosphere that have been increasing relentlessly. Here in this graph since 1958, this is sort of the iconic figure and time series of global change. The increase here is caused by the burning of fossil fuels, coal, oil, and gas, and the land use change, more explicitly, the cutting of the rainforest, and therefore the emission, about 10% every year of the global emissions are due to deforestation. You also see the extreme precision by which we have these data since 1958. You see this annual cycle of the carbon dioxide concentration in the atmosphere. This is nothing else than the breathing of the vegetation on our planet. In spring, the vegetation takes up carbon dioxide. In fall and winter, it releases carbon dioxide again through the falling leaves, if you wish. And so this is a very nice message of the breathing of our planet. Superimposed on the less nice message that this greenhouse gas concentration has been increasing since 1958. And in fact, you may wonder, what was the concentration before? Before we had this 47% increase since 1750. Well, we get that information out of polar ice cores. We go to Antarctica, drill ice cores down to about 3,000 meters depth, very close to bedrock. And that old ice that is as old as 800,000 years contains air, and that old air contains greenhouse gases, and these concentrations we're able to measure. These greenhouse gases are enclosed in bubbles of the ice throughout the 3-kilometer long ice core. And you see here the result of studies at the University of Berne and other universities in Europe that have been carried out in the last 15 to 20 years to establish the natural variations of CO2. CO2 is not constant. The greenhouse gas has natural variations. You see these natural variations over the last 800,000 years, 8 full glacial interglacial cycles. And at the very far right end, you see the concentration today, 2022, outside of any margin of variation due to natural origin. This is the result of burning fossil fuels, coal, oil, and gas. So what we can affirm as climate scientists is that there is unequivocal evidence that man has, through his activity, changed the atmospheric composition of greenhouse gases, and that has changed the climate on this planet in the last 50 years. Now then, the question arises, well, what is next? As we have affirmed in the 5th assessment report of the Intergovernmental Panel on Climate Change, in its summary of policymakers, that human influence on the climate system is clear. And just in passing, by the way, this statement has been approved in consensus by all nations of this planet. So it's a statement that comes out of the robust and hard scientific evidence, has passed all reviews, and has found the acceptance by all governments. This is quite remarkable, because at that day we still had many media messages that cast doubt on climate change and its anthropogenic origin. So the question then is, what is our future? And that is a question that is posed to climate science as well. We're using climate models to address this question. This is nothing than weather forecasting models in a more comprehensive expression that also include ocean circulation, sea ice, land vegetation, etc. You need supercomputers to calculate these future climates, and you need scenarios, as is usual for any future assessment. 2 scenarios I show you for simplicity here. A scenario that assumes that carbon dioxide emissions continue as business as usual. And you see the response of the climate system measured as the global mean temperature change. First, the historical period up to 2005 in gray, and then in red, that scenario. You see, we have in the 21st century, for this business as usual scenario, another 4 degrees Celsius warming in the global mean. Add to that the 1.1 that we had already up to the end of the 20th century, we are arriving at a whopping 5-degree warming since industrialization. 5 degrees, just to give you context, 5 degrees on our daily body doesn't really mean a lot. That's sort of a weather fluctuation, but in the global mean, this means a lot, because during an ice age, it was about 5 degrees colder. So we are speaking of massive climatic changes that would be ahead of us would we follow this scenario of business as usual. There are, of course, alternative scenarios. scenarios that phase out fossil fuels, as is foreseen by the Paris Agreement. We will look at that in a minute. And that is the scenario here to stop CO2 emissions. Not tomorrow, but to phase out CO2 emissions, which allows us to stabilize global mean temperature at a further plus 1 degree warming. Add to that the 1 degree that we had already, so we are at about 2 degrees. And you see the massive difference of these two emission scenarios also at the end of the 21st century. While the business as usual scenario easily projects into the 22nd century with further warming, you see the slope of that curve, the blue curve has already stabilized, and that stable temperature will continue in the 22nd century. Let's now look at issues that are closer to our heart and closer to our purse, and that is extreme events. One of the illustrative extreme events are heat waves with consequences such as this in 2021, the wildfires that have ravaged on the western coast of North America, in British Columbia, in Canada. Whole villages have burned down, people have died, damage was enormous. The question is, how often do these extreme heat waves actually occur in the past, in the present, and in the future? So a typical 50-year event should statistically occur once in 50 years. And you see that here illustrated in this visual, 50 dots, and 1 dot is red. That's the extreme event. Today, with 1 degree warming global mean, that 50-year event has become more frequent. And you see here more dots, about 5 dots that have been shown here in this graph. In fact, we have multiplied the frequency by a factor of 5. So it's no longer a 50-year event, but a 10-year event. For a 10-year event already at our present climate, we have health effects, something that people haven't appreciated for many years. Climate change can also affect your health, in particular if you're part of a vulnerable group. A study that was published last year out of the University of Berne with collaboration internationally, in particular with the School of Hygiene and Tropical Medicine in London, has looked at the mortality during heat waves from 1991 to 2018. And you see a range of countries from which data were available here on this circle. The question these researchers have posed is, how much of the mortality during a heat wave can we attribute directly to the increased heat wave by anthropogenic warming? That's a very interesting question, because down the line, this is also a question of responsibility. And it's interesting to see in all these countries, more than 0% of these attribution is possible. In fact, more than 40% is attributable in areas of South America. Europe doesn't arrive there yet, but is very close, in particular in Northern Europe, Scandinavia, you see in the pink colors, but also Southeast Asia and the countries in the Arabic Peninsula and environments are already above the 40%. If we then draw another circle indicating 60% of mortality is attributable to global warming, then you see some countries already stick out. And obviously with continuing warming, more and more countries will here be affected by these heat waves and the ensuing mortality that is experienced in vulnerable societies. Back to our heat wave frequency diagram here, you see one shot of the Mediterranean from 2022, June, which shows you an extremely hot bathtub. The Mediterranean has experienced extremely hot temperature during this year as part of the 2022 heat wave. And you see in a world of 1.5, that is the more ambitious Paris goal, or 2 degrees, our 50-year event occurs already 8 or 14 times in 50 years, statistically. And for a business as usual case with 4 degrees warming, already 40 times. This means that a 50-year event to which we had to adapt only once every 50 years, or now only once every 10 years, will become the new normal. The question is whether we are able to adapt to that, and where are we able to adapt to that. Now, having seen that example of direct health impacts due to extreme events, I think it's clear to go a step further in understanding the climate crisis as a resource crisis. Why is that? Because the heating affects the resource health. We've seen that. I won't go into the details how the global warming affects precipitation and therefore the resource water. But also sea level rise will affect negatively the resource land. Through the rise of sea level, we lose land. Hundreds of millions of people are actually living in low-lying countries and megacities close to the ocean. And finally, land use will affect the resource of biodiversity. So we can truly say the climate crisis is a resource crisis, and therefore it takes on a completely different dimension. Because we all know if we start discussing about resources, conflict is around the corner. We have experienced that in 2022 under dramatic circumstances. 0, this is an important number, a breakthrough in mathematics centuries ago. But 0 is also the number that follows from the Paris Agreement, which says that we need to stabilize global mean temperatures to no more than 1.5 or 2 degrees Celsius above pre-industrial. 0 refers to the fossil fuel emissions. And it's modified in the Paris Agreement. It's not 0, 0, but it's net 0. So if we manage technologically to draw out carbon dioxide from the atmosphere, then we are still allowed to emit some amount of carbon dioxide. But net 0 is not disputable. This is a scientific fact. If we don't arrive at net 0, we will not achieve the Paris Agreement in the sense of stabilizing temperature. And so 0 emissions of carbon dioxide, and of course, here include also methane as an important greenhouse gas, but today I focus on carbon dioxide. Now, to give you an impression on the urgency that we have accumulated in years or even decades of inaction, because already in the mid-70s, the scientists knew what the problem was, and they did communicate it. So the urgency has developed, and here I show you the numbers of the remaining carbon dioxide emissions so as not to violate the 2 targets that were set in the Paris Agreement. For 1.5 degrees Celsius, we have a remaining 318 billion tons of carbon dioxide. That's a number that is so big that doesn't tell you a lot. If I don't give you the global emissions per year today, it's 37 billion tons of carbon every year. And so we have about 8 years until that budget is exhausted, and therefore the global warming to 1.5 is committed, and the goal will actually not be achieved. You can say, well, I don't want to emit at current emissions for 8 years and then I have to go to 0 right away. I would like to have an exponentially falling path, and the rate of falling is not really encouraging, with over 12% of decrease of carbon dioxide emissions every year. Maybe the first 12% will be not so difficult. You could decide to stop deforestation right away. Then you have achieved 10%. But the next year you have to come up with another idea, an additional idea. So you see how ambitious that goal of 1.5 degrees Celsius has become. And if we had implemented that already at Paris time, we would have actually doubled the time. So it's really a matter of every year that actually eats out of that budget. For 2 degrees, it's less ambitious, obviously. We have another half degree warming that we can afford. So we have 1,070 billion tons of carbon dioxide. This gives us another 27 years. This is about just before 2050, the ominous number. Here we would have to start reducing every year by about 4%. That seems something feasible, but it's certainly not feasible if we don't do anything. So business as usual will not lead us to the minus 4% per year. So it's really urgent, and urgent is the decarbonization. Getting rid of fossil fuels, an absolutely superb technology, I must admit. All the development we had experienced in the last 150 years was possible through the availability, the cheap availability of energy through fossil fuels. Fantastic technology. But by now, the side effects of this technology are no longer acceptable, and increasingly so, and therefore we need to come up with a better idea, and that is decarbonization. It will concern all sectors. Every sector will need to decarbonize, ultimately every country, every region, everybody. And so what we are looking at is an industrial revolution. It's actually the fourth industrial revolution after mechanization, electrification, and digitalization. And in fact, industrial revolution bears some hope. It's actually a huge opportunity. That's the first indication of an opportunity. If you look back, industrial revolutions were always opportunities for individuals, for companies, for nations, for the world. So that is how, on the energy section, a sector decarbonization looks like, but it's much more, and it's fast. We have to, and if I can move forward, I would appreciate that. Maybe the battery is dead. Okay. In only 30 years, you heard the number 2050. This is an incredible speed. All our infrastructure has somehow to change in a way in 30 years. Is that possible at all? Well, humans have done changes much quicker. If you look at mobilization, this is the best mobility in the year 1900. Everybody was proud to have that form of mobility, the most modern way to move from A to B. Only 13 years later, seems to be a slow computer. Okay, the same street looks like this. 1913, that was the most modern, must-have form of mobility, only after 13 years. So things can change if people are convinced that we need to do something, and if the products are convincing. And I'm really slowed down, I apologize. We also need to change our habits. I will say it here, and everybody knows it. We need to change our habits in mobility, in the way how we get our energy. So mobility, cheap flying, over-dimensioned mobility, one person moving 3 tons of steel is not really the smartest way to get from A to B. These things need to change if we want to achieve net zero. On below energy, there are other ways, renewable energies, and obviously centralized energy will not go away totally. But we can decentralize the energy sector in a very significant way without affecting our economy. And finally, consumption is a topic as well. I just want to flag that here. The way how we get our food, that is responsible end to end for about a third of greenhouse gas emissions if you include the production of methane. So for all these pictures, there is an alternative. I go back. So this is what we are used to, kind of. Here is an alternative in a way. And with that, I'm already at the end. If we want to limit climate change, and we must do that, as the Paris Agreement clearly states, and if we want to achieve sustainability, and that is also laid down in the Agenda 2030 of the United Nations Sustainable Development Goals, then an ecological necessity and an economic imperative is climate protection. Thank you very much, and I'm looking forward to interact with you and discuss. Thank you.
Thank you very much for that. The next part of this presentation is about another half an hour or so where we will discuss how to, a little bit more in practice, how to seize this opportunity, or at least attempt to. And then we'll have time for some questions where Professor Stocker is also available. And I'm also being told to inform everyone that there are cocktails after this at 5:30, so everyone can be excited at this presentation. So the Paris Climate Agreements that we've just heard being described, what does that mean in practice? Well, this 3.8, we've rounded it up to 4. Essentially, to reach by 2050 climate neutrality, we need to reduce emissions by 4% per year. After the agreement, every country has gone to their own drawing board and decided on what their nationally determined contribution would be. So how much carbon will each country contribute to reducing in an effort to reach carbon neutrality by 2050. The issue is that there was no overall guideline as to how much this needs to be. And so when you tally up all of the reductions of each country individually, you arrive at a sum of carbon that is much higher than the carbon budget that the IPCC tells us we're allowed to have. This means that if nations just implement the targets that they've rolled out, we will by far not reach the targets at all. And this is where we would say that the private sector needs to also play a part. And of course, nations will adjust their targets as time goes on, but the private sector plays a key role in us achieving the Paris targets. What does a 4% per year reduction mean? It means by 2050 we have reduced carbon by about 70%. This is the plan. If you annualize 4% reduction over 30 years from 2020 to 2050, a 70% reduction is achieved. And in order to reach this zero number, we need to be net zero, and we need to sink this remaining 30% out of the atmosphere by carbon removal, either more forests or more technology that does that for us. So we're going to need, firstly, a conventional way of decarbonization. This is going to be the first priority. And the second priority needs to be a proliferation of technologies that will help us to take carbon out of the atmosphere. So we've already heard what the carbon budget is. We're about 1.1 degree above pre-industrial levels in terms of temperature. The numbers are slightly different here because we're talking about greenhouse gases, which includes carbon as well as all the other greenhouses, such as methane. And at 52 megatons per year, this means that for a 1.5 degree target, we would have very few years to achieve, and essentially it's probably without chance that we will reach it. So, of course, we haven't lost all hope, and there are many practitioners that are implementing solutions to try to help the world achieve this. In fact, we are one of them. We've committed many of our funds to follow a 1.5 degree target. But we also have to be realistic, and obviously if the world doesn't mobilize itself aggressively and quickly, this 1.5 target will not be achievable. The 2 degree target gives us a bit more time, and of course also allows a more gradual implementation of a transition towards net zero. but it's still very soon. I still plan to be alive in 2038. I would say, looking at people in this room, I would say most people will be as well, and definitely our children will be. And so this is not a problem in the future, this is a problem for now, and the later we leave it, the less time we have going forward. On top of that, this 4% reduction for 2 degrees is not currently being achieved. So overall, we actually have more than 1% increase annually. This means that we not only need to change by reducing carbon, we actually need to change very aggressively by stopping to produce more every year. Of course, what does this mean in the global context? Well, a lot of developed nations feel that they're doing their part and that reduction is taking place, and that is true to some extent. Developed nations, on average, at least up until 2018, have been reducing carbon by less than 1% per year. So, of course, they're doing more than the global average, which is an increase of 1.25, but it's still a far cry from the 4% that's required. In addition, developed nations only account for about 1/3 of the total pollution globally. 2/3 of the pollution is being generated in developing nations. And those nations are actually increasing carbon aggressively, and this minus 4% is a very far vision for them. In fact, many major economies in developing nations have declared a net zero goal in years much later than 2050. So we have China and India that are 2060 and 2070. Therefore, if we are to reach the Paris targets, we will actually need to reduce a lot more in the rest of the world to compensate. And this is actually in line with this concept of fair share, because the UNFCCC, so the United Nations group that specifically looks at climate change, has determined this fair share concept that these Annex I countries, which are the developed world that have essentially polluted a lot more in the past, they've gone through the Industrial Revolution a lot sooner and used that pollution to promote itself into a developed economy, this pollution is still in the air. And developing nations have not had that chance yet. And therefore, there is a fair share principle where developing nations are entitled to pollute a bit more than developed nations, and there should be a compensation procedure there. But the key message is the solution needs to be a global one. There is no point looking at our own global market and reducing by 4% or maybe only 75 basis points when the rest of the world pollutes a lot more and is still increasing. And this brings us to some recent examples. For example, there have been in Germany and Poland and all over the developed world protests against the development of new coal-fired power plants. Now, of course, this is a great step forward, or at least not a step backwards anymore, but it's a little bit irrelevant in the global context when you realize that 1,400 coal-fired power plants are being constructed right now in the world. These alone, once they're in operation, will increase global pollution by more than 2%. So this is versus the -4, we're going to be at +2 just from the creation of these coal-fired power plants. On top of that, 40% of the financing of these coal-fired power plants is coming from Annex I countries and corporations within those countries. So Annex I countries are the developed ones that are trying to reduce carbon at home, yet we're financing pollution abroad in huge scale. At the closing of Professor Stocker's presentation, he talked about consumption habits. Of course, if we look at Switzerland, things look like everything is rosy here because we have very tight climate targets that are being implemented. We have very good regulatory control over pollution of our industries, and on the other hand, we're not actually counting everything. What we're trying to reduce is pollution within our own geographical frontiers. So of course, we're doing great on that and we're regulating it well. But if we look at the imported consumption and the pollution that this generates, we're by far one of the biggest polluters in the world. Switzerland ranks number 16 in the pollution per capita if you count production pollution. So when we receive a plastic toy for free with our meal or our kids' meal, this toy is basically free here, but it's generated tons of carbon in another country. And this needs to be accounted in our own personal choices. And moreover, when we have a global perspective, we need to bear in mind how money flows and how consumption here generates pollution abroad. To exemplify this concept as well, we have China. Obviously, most people wouldn't be surprised to hear that a huge part of the manufacturing happens there. 28% of all manufactured goods in 2018 were manufactured in China. And this actually corresponds to approximately the share of pollution of China relative to the rest of the world, 27%. But their consumption, of global GDP is only 13%. This 15% gap, approximately, of course the measures don't measure exactly the same thing, means that this is exports. So they produce 28% of the world's goods, consume 13% of them, therefore 15% of the stuff they produce is sent abroad. And that is basically the developed nations externalizing pollution to developing nations. And so we cannot be surprised if China, with coal-fired power plants, is polluting and is on the upside in its pollution if we consume goods that are produced there and we don't enforce stricter production principles, and we're not ready to pay the premium that may come with that. What does it mean to reduce 70% emissions by 2050? Well, in parallel, we have this issue of having to reduce and decarbonize, but we also have an issue that the economy should grow as well. So we're going to have to pollute less and produce more. This means that, 70% reduction in pollution, in parallel with, if we assume a 5% GDP growth, which in the current circumstances seems very optimistic, but regardless, we're going to have an economy that's multiple times bigger by 2050 than it is now. And therefore, with 5%, we assume that the economy needs to be 15 times more efficient in terms of the economic production per ton of pollution that's being generated. And this is a huge challenge. And this means also that resources needs to be focused on how do we get there? How do we make things more efficient in terms of pollution per production? What does it mean for investors? Well, there are two things. There's physical risk and transition risk. As an investor, investing in a company whose business model will no longer be valid in 2050 is a huge risk. Maybe the company operates in, let's say, fossil fuel. It has huge coal reserves underground, and part of its balance sheet is valued on the coal that's underground. Well, in 2050, everything going well, we're no longer burning coal. So all of the coal that is in the ground is becoming worthless, and therefore part of the balance sheet is essentially stranded assets. As investors, this is a huge potential risk and doesn't only apply to fossil fuels. It also applies to business practices. If a company has maintained high profitability by dumping its externalities unchecked on the world, and by 2050 those practices are no longer allowed, either because of regulation or because consumers won't stand for it, that profitability will no longer be as high, and the valuations will crumble as a result. On top of that, there's physical risk, which need to be assessed. Physical risk affects pretty much everything and everyone. It's the risk that, as we see, the natural disasters can wipe out entire cities and can destroy an entire company. What happens if a company's factories disappear in a flood, or if there are fires and the company can't operate for a certain amount of time? So you have companies that are highly exposed to these risks, and you have nations that are also highly exposed to these risks. And these risks need to be taken into account when investment decisions are made, and investors need to pay very close attention to them. But as mentioned in the first part of the presentation, it's not all doom and gloom. There are also opportunities that stem out of this. It's estimated that in emerging markets alone, by 2030, there's over $23 trillion of market value to be generated in providing solutions to the climate challenge. So companies and states that come up with solutions to these challenges will have extremely high demand for whatever they produce if it's a good product. When we went from horses to cars, it was a good product, there was demand. Hopefully now we can find the next generation solutions, and there will be demand for them. What does it mean technically in terms of implementing a fund strategy? Well, what we do is we've taken the global carbon budget that was set by the IPCC in 2020, and using this 4% reduction, we're making sure that our funds that are aligned with the Paris targets will follow the climate targets. So whether it's a fund that follows a 2 degree target or a 1.5 degree target, it will have a more or less aggressive reduction. But this means that we have annual interim targets to reduce pollution by 4% or more for the 1.5 degrees. And by 2050, we will have achieved this 70% reduction. We achieve this by voting and engagement, so stewardship on the markets, trying to get companies to improve their business practices, and investing as well in companies and states that will follow through on plans towards net zero. So if an issuer does not follow a transition to net zero, it is likely not going to be a valid investment going forward until 2050. Why do we do this? Well, multiple reasons. Firstly, we believe it's a societal responsibility for ourselves, future generations, and for investors. We believe that sustainability metrics are material throughout all asset classes. And extremely importantly, we believe that sustainability is material for financial returns, whether it means reducing risks or optimizing exposure to opportunities where there is going to be a significant upside. For us, we believe that there is no difference between protecting the environment in a sustainable way and protecting investor returns in a sustainable way over the long term. However, this also has to be encompassed in a global, holistic sustainability strategy. We can't just look at carbon. Everything else has to be taken into account as well. When we talk about a resource crisis, we're also talking about potential conflict and all of those things. And there are more metrics than just environmental. We need to bring into account environmental, social, governance. We need to look at what companies are doing, whether it's through controversial sectors or controversial business practices. And we also need to seek for opportunities where there are some. So, for example, if a company or a state is going to be promoting solutions that can help us achieve the SDGs, this is going to be a very attractive business proposition. At this point, maybe for the practitioners in the room, I thought I would give 3 practical examples of what this means in terms of having our strategy applied throughout a global strategy, but also across all asset classes. When we look at corporations, we have also some challenges. So for those who are not familiar with the greenhouse gas protocol, you have 3 different scopes of greenhouse gas emissions. Scope 1 are the emissions that a company or state, but let's talk about the corporate for a while. A company generates pollution by running its operations. So if it has a corporate vehicles or its factories, or if it's manufacturing something, it's creating pollution. Scope 2 is the pollution that it generates through the purchase of electricity, where a company already has a choice how it operates. So a lot of companies can choose to buy renewable energy and thereby reducing their Scope 2 emissions. Scope 3 emissions are the emissions that are generated when the company purchases a product from its suppliers or when it sells a good or a service to its customer, and that product pollutes in the future, so the downstream. So to take a quick example, if you have a hotel, one hotel outsources its laundry service, whereas another hotel does it in-house. The hotel doing it in-house will have much larger Scope 1 emissions, whereas the hotel that has outsourced it has very low Scope 1 emissions. So it's important to take into account the Scope 3, where that outsourcing would happen. Otherwise, we do not get a holistic picture. But one of the key challenges of the industry today is how do you take that into account when you realize that, firstly, there's double counting, because a customer has a company as its supplier, and so you're counting Scope 3 emissions multiple times. And in the grand scheme of things, on average, 88% of all emissions, when you tally them up, are Scope 3. And if you just look at the aggregate number, it means that you should focus on Scope 3. But if you do that, then you're no longer focusing on what a company actually does in terms of its operation. And so there are some challenges in terms of what a company can affect, which is mainly its scope 1 and 2, and sometimes its scope 3 is not manageable. So if you're selling screws, whether your screws goes into furniture, which is relatively low emissions, or whether it goes into airplanes, where it has high emissions, there's a huge difference in scope 3. And maybe the screw manufacturer has no control over where these products go. And so it's a fine balance between integrating the information, but not following the data exactly as if it was a perfect science. Another challenge that we have is in sovereign fixed income, for example, where if you take a global benchmark, you have 3 countries emitting 2/3 of the carbon intensity of the portfolio. This is because of 2 factors. First, the fact that these countries are very well represented in the benchmark, so they issue most of the debt. And those 3 countries, China, US, Japan, have huge carbon intensities themselves. And those countries do not provide green bonds, which means that to manage a global fixed income sovereign portfolio with a climate strategy, you need to bear in mind that there is going to be significant tracking error coming from the climate strategy. And of course, the climate strategy is very important within the context of a portfolio, but we have to remember that one of the main aims of the portfolio is to generate financial returns. And so we don't want to take excess risk just for climate. And so it's important to merge the 2 into a holistic strategy that looks at climate with the perspective of return, and as well as the other sustainability factors that can affect investment decisions. Another challenge is in real estate. On the left, you have a table that shows how we prioritize real estate properties that we would want to acquire and renovate. So the EMO score is a general score that highlights the attractiveness of a real estate property, whether it's to do with returns, the location, and so on. And on the horizontal axis, you have the cost it would take to reduce per ton the pollution of that property. And so what we do is we look at priorities and we say, okay, the ones that are in the top left quadrants are more attractive and have a cheaper way to reduce the pollution of that property. But this all rests on the assumptions also of the future price of carbon, because when you renovate a piece of property, this is a 30+ year investment. And so right now, carbon credits, for example, in the European Union are trading at about 65 francs per ton. But in a few years, maybe it's going to be a lot more as the targets become a lot more clearer for countries and regulation becomes tighter. And therefore, we need to plan this. Now you see it. So going forward into the future, we have the later priority piece of real estate that will be focused on when the price of carbon matches that. And this is how we intend to reduce carbon through a real estate portfolio. So, in conclusion, climate change is a global challenge and it requires a global solution. There are several dimensions of sustainability that need to be integrated. There's a lot of nitty-gritty stuff that needs to be looked at and integrated in a smart way, because you don't want a sustainability strategy destroying the returns, which are also core in an investment. We have 2 principal levers, which are capital allocation and stewardship. And of course, stewardship is probably the more, let's say, fundamental way of improving a portfolio, because we, by the same means, improve markets, and we have the collaboration of other market participants on that. We also join on joint initiatives where the bargaining power can be huge relative to companies and sometimes even at the state level. But overall, we need to, if the market does not adjust, we need to adjust the portfolio and lead the market forward through capital allocation and change the cost of financing for market actors. Climate change provides a lot of risks that need to be mitigated, but we are optimistic and we do look at the opportunities that they can generate, and we hope to capitalize on them. Time is running out and the time is now. Thank you.